Hello and welcome. In this lecture we are going to discuss about self-referential structures. So we'll start with the definition part. So the basic definition is that self-referential structures are those structures in which one or more pointers point to the structure of the same type. This is the formal definition of what is self-referential structures. Okay, that means these are those structures in which definitely there will be pointers, because we are talking about in definition, and they point towards the same structure type. So how it can look like, suppose I'm just simply writing the structure format. Suppose I want to have one structure, so I will be writing the keyword struct. Okay, this is for defining the structure, and suppose this is my structure name, and definitely this is the boundary, and inside this I will be defining the member function. Now the condition for self-referential structure is that one or more pointers, that means pointers will be the data members inside. So let's say I have integer p, this is normal, and then I have another member which is struct self, and then that means it is a pointer of struct type, and this pointer is going to point itself. So it is going to point back here. Okay, this is the formal definition of self-referential structures. Now we will be understanding that by writing a simple code over here, that what actually meaning of this self-referential term and how it is done. Okay, let us take an example in which I'm going to create a structure with a code, and what happens, we will be seeing the memory visualization as well. So let's start with the boundary of structure. Okay, so when I write struct, and I have made a structure with the name of code. Okay, now this code consists one integer variable I. Okay, why it is not? Let me clear it first. One integer variable, come back to pen, one integer variable I. Okay, another character variable C, and definitely because we are talking about the self-referential, so I will be struct code, and this is going to be a pointer. Okay, so this is my definition of struct or structure. Now up till now we have only declared the structure, no memory has been allocated. So for allocation of memory, as you remember in my previous videos, we had a discussion that once in the main program you create the variable, then only the memory is allocated for the structure. So let's write the main code this side. Okay, let's make it here. So in my main integer main, Now when I start this main code, now let's start with one of the variables. So I have to write struct, and what is the name of the structure? It is code here, and then I want to declare a variable, let's say var1. This is what I have declared. Now in variable 1, suppose I want to assign values, I want to access the element var1.I. Once I use this dot operator, that means now I am accessing one of the data members, and if I write 65, I have assigned the value. Now let's say var1.C, so I can assign here A, and we have the third data member, which is a pointer. So var1.ptr, which we have declared. Now remember, ptr is a pointer, so we cannot simply assign a data value. We assign a address value, or we can assign here null. So let's say this null is present over here. Now let's take a pause over here in this code before writing some other things. Let's see that how it will look like, what will be the memory visualization of this variable. So let's make okay. So once I write in the space of I, the value was let me see over here, the value was 65, A and null. Okay, so the value will be here 65, here it is A, and here it is null. So this is the visualization of variable 1 in the memory itself. Okay, this is what is happening when we declared it. Up till now we have not utilized or printed anything. Now let's go back to the scenario, because we are talking about self-referential. Let's go back to the scenario. In this, now let me change the pen color. In this, what we will be doing, we will be creating another variable. So let's say struct code, and now I am creating another variable of variable 2. Now with this variable, what I am doing, var2.I is equal to 69. Okay. var2.C is equal to, let's say, S. Fine. And var2.ptr, again, because it is address, and if I do not have any address value, I will initialize it with null as of now. Okay, now let's look what is the memory visualization of this variable 2 in this case. So we will be having, okay, so I have given here 69, here S, and this is again null. Okay, this is the representation for variable 2. Now when I say that it is a self-referential, or when I say that it is a pointer, so I need to provide an address to the pointer. Now what is happening up till now, that we have only written 2 variables, but they are not self-referential. Now to make it a self-referential, what we will be doing, because this particular pointer is self-referential, if I simply write, let's say with a green pen, if I simply write one line of code, variable 1.ptr is equal to, if you remember the operators, ampersand var2. That means now we are providing the address of variable 2 to the pointer of variable 1. Okay, and now if I simply write a printf statement and try to print the values of variable 1 dot ptr. Now ptr is my pointer. Now in this pointer I am containing the address of variable 2, and remember this earlier we were only using dot operators, but in case of pointers, to access the pointers you need to use this arrow operator. I and variable 1 dot ptr, and now my pointer is pointing to C. Okay, I believe whatever I am writing here in this, you try to execute that in your experiment. Now when I write this, what actually happens in case of visualization? Come again to this visualization location, and let's suppose that the initial location of memory, this is assumption, here is this, and for variable 2 is this. This is for simplicity. Now what is happening when I provide here, because this is the pointer for variable 1, this is what I have done here. Pointer of variable 1 is fitted with the address of variable 2. So when I say address of, that means the initial address value. This 2000 is fed over here. So now my memory will be like this, in which this 65 is here, this is here, and here we have the address. Okay, and because of this address, what is happening, because it is 69s and this is still null, because this is already this address, that means now we can refer to this location. So using variable 1, we can access the value of variable 2. Okay, this is self-referential. Now here is your task. By seeing the same example, here is your task. The question is, I will be writing here the question for you. Here is your task. Write a C program to create self-referential student structure. Okay, now you have to simply access record of one student through another. Okay, by using this address scheme you have to do that. This is the assignment for today's class. Now how it is useful, so I suppose you have already studied or will be studying in next videos, that the basic example or the best use of this referential theory is linked list. Linked list is the example which we are going to cover. That's all for today's video. Thank you so much.